So before getting deeper into the reefer system, let's talk about latent heat, sensible heat, specific heat capacity, dry saturated steam, wet steam, superheated steam, liquefaction, evaporation. तो पता है, we know that, but something different I want you guys to know. Then specific volume and critical temperature. Oh God, so many things. Why the hell is this important? Yes, it is. Not just for interview, but also for understanding the basics of reefer system. What is sensible heat? Normally we know, yaar, we take
a message for every marine engineer out there. First time joining in, scared of what will happen on board? Our Combat Achiever packages show real shipboard videos before you step on, so you join with confidence. Junior engineer, still repeating those basic mistakes? Our basic troubleshooting package helps you avoid the same errors we all made on board ship. Fourth engineer, go in depth into purifiers and compressors. Izzat nahi kamani kya? Third engineer, learn auxiliary engine overhauling and boiler testing step by step. To all second engineers and chief engineers and ETOs, hydraulics, maneuvering, electrical circuit diagrams, PLC, PID, reefer and AC system. Guys, troubleshooting should be your forte. अगर जहाज पे इज्जत अपने juniors की चाहिए, तो troubleshooting आनी चाहिए. 24 packages, many more coming soon. 2-year subscription. That's MNDFLIX, not a course, but a technical lifeline you need on ship. Check out our free trial videos. Link is in description box.
Say water, it is at 0 degree centigrade and I heat it over here. I know I am giving heat energy, the temperature will increase. So if I put a thermometer over here, I see the temperature is increasing. That means heat is coming over here. This is sensible heat. Sensible heat means, okay, I can see, because normally what does heat mean? If you are giving heat, temperature is increasing. So sensible heat means temperature is increasing over there. So it is sensible, makes logic. Now why I am showing so? Another is latent heat. What is latent heat? Hidden heat. Latent का मतलब होता है hidden. Hidden heat. When you have got ice, this is ice. Say this is ice at 0 degree centigrade temperature and you start heating it. Put a thermometer over here. You will keep heating it. The temperature will remain at 0 degree centigrade till the time it converts into 0 degree, all converts into 0 degree centigrade water. Right? So where is the heat gone? The temperature is not increasing. This is latent heat of fusion. Another, we take water at 100 degrees centigrade and start boiling it. At 100 degrees centigrade at 1 bar atmospheric pressure, water starts boiling. So what is actually happening? Heat is going, but temperature is not increasing over here. Again, latent heat of vaporization. Let's talk about specific heat capacity and heat capacity. What is heat capacity? Heat capacity is amount of heat required to raise temperature by 1 degree centigrade. That means you have got, say, water over here, 10 kg. Then you start heating it. 10 kg water and you start heating it. If the temperature was 10 degrees centigrade and now it becomes 11 degrees centigrade, the amount of heat given for raising the temperature from 10 to 11 degrees centigrade is the heat capacity. Done, guys? Now, what is specific heat capacity? Amount of heat required to raise temperature of unit mass, say 1 kg by 1 degree centigrade. What does that mean? अब यहाँ पर ये 10 kg नहीं होगा, it will be 1 kg. Then only whatever heat I get for changing temperature from 10 to 11 degrees centigrade will be C. Now why is this important? See, understand. When I talk about heat energy, say I have got 1 kg water over here and temperature is, say, 10 degrees centigrade. Now, if I have to raise temperature by 1 degree centigrade. Now guys, एक बार वापस जाते हैं गैस लॉज में, एंड आई हैव ड्रॉन देयर Q इज इक्वल टू N C delta T, right, where N is number of moles, C is molar specific heat capacity of the gas, and delta T is the temperature difference, right? So over here Q will be M into C into delta T, where number of moles of gas is replaced by mass of the liquid. So suppose I know that C value is 300 joules. This means 300 joules of heat is required to raise temperature of 1 kg water by 1 degree centigrade. So if I have to increase temperature of 1 kg water by 10 degree centigrade, then it will be into 10. Now, but if I have to heat not 1 kg but 10 kg water, then Q will be 10 into 300 into 10, this much amount of joules. When I am talking about C out here, I am not putting the exact unit, guys. That will be put later. Okay? Clear? So amount of heat energy matters specifically. Now, what is heat capacity? Heat capacity says amount of heat energy required to raise a temperature by 1 degree centigrade. It does not matter whatever is the mass. So M into C is heat capacity. Right? Understood? Okay. Now we'll start with dry saturated steam and wet steam. Dry saturated steam and wet steam. Okay, let us take a flask or a jug of water. Okay, and let us heat it. So we bring it to say temperature of 100 degree centigrade. Okay, 100 degree centigrade, and pressure acting is atmospheric pressure is 1 bar. So what will happen? Water will start evaporating and converting into steam. Now guys, at that I told you for 100 degree centigrade 1 bar is vapor pressure when I talked in pumps for NPSH and all. So similarly out here, understand one thing, कि it is also known as saturation pressure and its corresponding saturation temperature. भाई जहां पर wherever state is changing, that means it is saturated. I have to change the fucking state. So at that point where it is about to change the state, whether from vapor to liquid, liquid to gas, gas to liquid, whatever it is, the pressure and temperature both are saturated pressure and saturated temperature. Done? So when I talk about dry saturated steam and wet steam, when it comes to saturated means the temperature, if pressure is 1 bar, temperature has to be 100 degree centigrade. Now, so the steam that I get at 100 degree centigrade over here is saturated steam, right? But since it has got water over here, so along with steam, some amount of water molecules are also going to come. So that is why it is wet steam, right? Now suppose all the water is getting evaporated, no water is left. In this steam, it becomes dry saturated steam because temperature is still 100 degree centigrade. Yes? Now suppose this steam out here, I am further heating it. I am further heating this steam. What will happen? Now 1 bar pressure पे 100 degree centigrade is the saturation temperature. That is saturated steam. It can be wet, it can be dry. And yes, once again in this, if I say dryness factor is 0.8, it means 20% water vapors are there. means 0.2 is wet. That means 20% water vapor are there. You also need to know a bit about this as well. Now, suppose after at 1 bar 100 degree centigrade, all the water has evaporated. Now, if you are further giving it, what will happen? Now, slowly the temperature of this steam will start increasing. So, now 1 bar pressure, temperature was first 100 degree centigrade. All the water has evaporated. Nothing to evaporate further. So, now it is full steam at 100 degree centigrade. This is dry steam because even the water vapors have been evaporated which were in the steam content. Dry saturated steam. Now what happens? Now if you are further heating it, slowly the steam temperature starts increases. 1 degree, 101 degree centigrade, 102 degree centigrade, 103 degree centigrade, 104 and simultaneously. Now guys, up till now it was saturated temperature, but now the temperature has started increasing. So now this is superheated steam. Heated nahi, superheated steam, and this is called degree of superheat. So whatever temperature above 100 degree centigrade is a degree of superheat. So if the temperature reaches 104 degree centigrade of steam, that means 4 degrees superheat. If the temperature reaches 110 degree centigrade, that means 10 degrees superheat. Right guys? This is very important for you to remember. This will help you with the thermostatic expansion valve. Understanding proper functioning. So I hope you remember that.